Hi guys! Today I can write equations of quadratic functions using vertices, points, and x-intercepts. I can write quadratic equations to model data sets, and I can solve real-life problems. Let's start with writing equations to model data. When a data set has equally spaced inputs, or x-values, you can analyze patterns in the differences of their outputs to determine what type of function can be used to model the data. So how can you tell if a data set represents a perfect linear model? Well, it depends on if you're given a graph or a table. If you're given a table and the x values are equally spaced, the y values should have constant first differences. Okay. The graph should be a line. Okay, because again, it's a linear model. So it can either be a line with a positive, negative, zero, or undefined slope. How can you tell if a data set represents a perfect quadratic model? If it's a perfect quadratic model and you're looking at a table, you should see equally spaced x values. Okay, the x values are equally spaced, and the y values have constant second differences. Okay, and if it's a quadratic model, you should see a U-shaped graph. Whether or not the graph opens up or whether or not the U-shape opens down is going to depend on your data set. Today we are looking at perfect linear and quadratic relationships, where every point lies on either the line or the parabola. Please note that in real-world events, that it doesn't always follow a perfect linear or perfect quadratic model. If the data has a trend, we can find the line of best fit or the parabola that best fits the data set. In the next lesson, we'll talk more about how to calculate linear quadratic equations of best fit when given a data set that follows a trend. So today we're not looking at data sets that follow trends, we're looking at perfect data sets that all the data points either fall on a line or all the data points fall on a parabola. So in example 1, it says determine which equation would model the data, linear, quadratic, or neither. So let's look at part A. The first thing I want to make sure of is that we have equally spaced x inputs so that we can analyze the y outputs. To get from -3 to -2, I'd have to add 1. To get from -2 to -1, I'd have to add 1. I'd have to add 1 to get 0. I'd have to add 1 to get 1. I'd have to add 1 to get 2. And I'd have to add 1 to get 3. Okay, so now that we've confirmed that our x inputs are equally spaced, now I can look at the y outputs. Remember, the y values have constant first differences for linear models, and the y values have constant second differences for quadratic models. We also have an option to put neither as part of our answer for example 1. Okay. To get from 9 to 4, I'd have to subtract 5, right? If you aren't sure, do 4 minus 9, you get -5. How do I get from 4 to 1? I would have to subtract 3. Right? Again, if you're not sure, go ahead and just do 1 minus 4, and you can see you'd get -3. How do I get from 1 to 0? I'd have to subtract 1. How do I get from 0 to 1? I'd have to add 1. Here I'd have to add 3. And here I'd have to add 5. So the first differences were not constant. Let's try for second differences. How would I get from -5 to -3? I'd have to add 2. If you're not sure, do -3 minus a -5, and you would get +2. How would I get from -3 to -1? I'd add 2. Here I'd have to add 2. Here I'd have to add 2. And to get from 3 to 5, I'd have to add 2. That means that we have constant second differences. which is a characteristic of a quadratic model. Okay. All right, let's take a look at the next data set. Confirm that we have equally spaced x inputs. I add 2, 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 and I add 2. So it looks like all of the x values are equally spaced. Now let's analyze the y outputs. To get from 3 to -1, what would I have to do? Or what is -1 minus 3? That's going to be -4. So see if that works. If I subtract 4 from 3, do I get -1? Yes. How do I get from -1 to -3? If you're not sure, do -3 minus the -1. That would end up being -2. How do I get from -3 to -6? I would subtract 3. How do I get from -6 to -8? Subtract 2. How do I get from -8 to -13? Or what is -13 minus a -8? That'd be -5. How do I get from -13 to -15? Subtract 2. Okay, so you can see that the first differences are not the same. They're not constant. So let's look at the second differences now. How do I get from -4 to -2? Or what is -2 minus a -4? That would end up being 2, right? I would add 2. How do I get from -2 to -3? I'd subtract 1. And really, I don't have to go any further. Do you see how those second differences are already not the same? If I go from -3 to -2, you could do -2 minus a -3. That would end up being +1. Okay, and I'm not even going to go any farther. This is going to be an example of neither, because the first differences are not constant and the second differences are not constant. All right, last but not least, again, make sure we have equally spaced x inputs. +2, +2, +2, +2, +2, and +2. That looks good. They are all equally spaced for the x values. So now let's analyze the y outputs. How do I get from 3 to -1? Or what is -1 minus 3? That is equal to -4, right? If I subtract 4 from 3, I get -1. Again, here I'd be subtracting 4 from -1 to get to -5. Here I'd subtract 4 to get to -9, subtract 4 to get to -13, subtract 4 to get to -17, and subtract 4 to get to -21. So I'm not even going to look at the second differences because we already can see here that we have constant first differences. So this is going to be a linear model. All right. Let's go through and just review our different forms. If we're talking about a linear function, we have two forms. We have slope-intercept form and we have point-slope form. In both forms, what does m represent? M represents the slope. Okay, and what would b represent in slope-intercept form? B is the y-intercept. Okay, and we would write the y-intercept as 0, b. And for point-slope form, what is x1, y1? That is just any point on the line. Okay, and let's review the different forms for quadratic functions. The first form that we have is called vertex form because it allows us to easily identify the vertex. Most of the real-world graphs we're going to be working with aren't going to have a horizontal stretch or shrink. So if this b value right here is equal to 1, another way that you can write the vertex form looks like this. Okay, the left-right, up-down shift will determine the vertex. So we will say that the vertex is h comma k. And xy represents any point on the curve or on the parabola, the U-shaped graph. Intercept form is where we can easily identify the x-intercepts. Here the x-intercepts are P and Q. We'll write them as ordered pairs, P comma 0 and Q comma 0. And again, xy is just any point on the curve or on the parabola. Standard form is ax squared plus bx plus c. The a value still indicates the vertical stretch or shrink, and if there was a negative out front, that would still be a reflection, that would flip the graph. The b value is not the same in standard form as it is in vertex form. Please notice that in standard form there's no h value, so you don't know the left-right shift of the vertex. Remember, to get the x value of the vertex, we need to use negative b over 2a. Okay. The c value indicates the y-intercept, so if you want the y-intercept, that's going to be 0, comma c in this form. Notice that there's no k value, so we don't know the up-down shift of the vertex. So in order to get the y value of the vertex, we're going to need to plug in whatever the x value is that we got from the negative b over 2a. Okay, so the vertex in function notation, we write it as negative b over 2a, f of negative b over 2a. xy, again, is just any point on the curve or on the parabola, the U-shaped graph. All right, now that we've reviewed that, let's go ahead and go to example 2. We worked on this last note lesson. It said use the given information to write the equation of the parabola. So in the first example, part A, we see that we're given the vertex. So which form would we use to help us write the equation? Would I use vertex form, intercept form, or standard form? Well, if I'm given the vertex, I'm going to use vertex form. All right, and when writing vertex form, we're going to go ahead and just use the one where the b value is 1. I'm not going to give you a horizontal stretch or shrink here. Okay, so I'm going to write down y equals a x minus h squared plus k. And I know my vertex is 2, 3. Okay, the vertex is your h comma k, which in this case is 2, 3. And I also need a point, and it tells me that a point on my parabola is 0, 5. So I'm going to make sure to plug in an h value of 2, a k value of 3, an x value of 0, and a y value of 5. All right, let's go ahead and take a look at that. So what is y? Y was 5. A we don't know. X was 0. H is 2. And k is 3. Let's go ahead and simplify this. 0 minus 2 is negative 2. Let's go ahead and square the negative 2. Anything squared becomes positive, so negative 2 squared is going to become 4. So I get 5 equals 4a plus 3. Okay, and now we have to start getting a by itself. I've got to solve for a. So I'll subtract 3 from both sides. We get 2 equals 4a. And to finish getting a by itself, we divide both sides by 4, and we end up getting that a is 1/2. That's what 2 over 4 simplifies to, is 1/2. Okay, so now that we know that, let's go ahead and rewrite the function now that we know what a is. So my final answer is going to be y equals, what was a? A was 1/2. X minus h, what was h? H was 2. Plus k, and k was 3. Okay, and again, for this example, we use vertex form because we were given a point and the vertex. Okay, if you're given the vertex, use vertex form. For part B, we have x-intercepts that are given to us, so we're going to be using intercept form. Right, our 3 choices are vertex form, intercept form, and standard form. In this case, we're going to use intercept form, which is a, x minus p, x minus q. Y equals a, x minus p, x minus q. Okay, it tells me my x-intercepts are -2, 0, and 1, 0. Remember, x-intercepts are your p comma 0 and q comma 0. So that means that I'm going to use, let's see, p is -2, and we'll say that q is 1. And then we also have a point on our parabola. Remember, a point on your parabola, just a regular point, is x comma y. So I'm going to say that x is equal to 2, and I'm going to say that y is equal to 8. All right, now we have our information to plug in. Let's go ahead and plug it in. Y was equal to 8, equals a. X was equal to 2. P was equal to -2. So be careful here. You had x minus p. So you have 2 minus a -2. And then we have x minus q. Again, x was 2 minus, and then q is 1. All right, I got to solve for a. We'll have 8 equals a. This becomes 2 plus 2, which is 4. And 2 minus 1 is 1. So I'll get 8 equals 4a. And then we'll divide both sides by 4. 8 divided by 4 is 2 for a. Okay, now that I've got that, let's go ahead and just rewrite our original equation here. We are going to have y equals, I know that a is 2 now, x minus p, p was -2, and x minus q, q was 1. So I get y equals 2 times x plus 2 times x minus 1 as my intercept form. All right, coming down here, it says write a quadratic equation using 3 points. All right, so let's take a look at what we're given in example 3. In example 3, it prompts us to write an equation, a quadratic equation, using 3 points. Notice it doesn't say anything about a vertex, and it doesn't say anything about an x-intercept. So we're probably not going to be using vertex form or intercept form to help us here. First of all, remember x-intercepts are in the form of number comma 0. That's what an x-intercept looks like. It's got 0 as your y value. Do you see how there's no y values of 0 here? So I know that I have not been given x-intercepts. So that's one reason why I'm not using x-intercept form. Let's talk about why we wouldn't use vertex form. Remember, the vertex is the highest or lowest point on the graph. So if I look at my y values, it looks like starting here, my y values start to go up. They're getting greater and greater until I get to 32,100, and then it starts to go down again. So if I was going to guess at the vertex, I might guess this. But really, see how this makes a jump from 30 to 35? We have no idea what's happening at 31. Maybe there's an even greater y value at 31. We just don't know. All right, so I can't use vertex form here either because I'm not quite sure what the vertex is. So what do we do? This is an example where we're going to use standard form to help us. We're going to write a system of equations and solve it. Okay, that's why we went over system of equations in Unit 1. Let's just remind ourselves what standard form looks like. Ax squared plus bx plus c. And again, we're using standard form because we don't know the vertex or the x-intercepts. Okay, so we have to set up a system. For our first equation in this system, we're going to use the point 10, 26,900. Okay, for the second equation in the system, we're going to use the point 15, 29,025. And for my third equation of my system, I'm going to use the point 20, 30,600. Okay, and that's what the directions directed me to do, was to pick 3 points to use here. You really could have picked any 3 points because we're only working with perfect quadratic models today, so I just picked 3 points that would land on the parabola to use. I chose these 3 because they were just the lowest t values. Okay. Oh, that's another thing we should discuss. Do you see how our variables are t and h this time instead of x and y? In this case, t is my input value and h is my output value. We just changed the variables since it's a real-world problem where we're referring to time and height. Using t and h makes more sense so that when you solve the system, you know what you're talking about. Are you talking about the time or the height? All right, so let's set up these equations. If I'm using each one of these points, remember the first coordinate is your x-coordinate and the second coordinate is your y-coordinate. And I'm plugging each one of these points into the standard form equation. So what's my equation A going to look like? We have y equals, so what am I going to plug in for y? 26,900 equals ax squared. What's x in this case? X is 10 plus bx. What is x again? 10. Then we have plus c, right? So what's that going to simplify to for equation A? We're going to get 26,900 equals, this will be 100A plus 10B plus C. Okay, so that's what I'm going to use for my equation A. Okay, now let's talk about equation B. We're using the second point, 15, 29,025. Again, what was my y value? My y value was 29,025 equals ax squared, x was 15, plus bx, what was x? 15, plus c. Okay, let's simplify this. We would get 29,025 equals, see 15 squared is 225, so we have 225a plus 15b plus c. All right, and then we've got to write an equation for c. We're going to be using the point 20 and then 30,600. So we'll start with 30,600 for y equals ax squared, x was 20, plus, let's see, b times, again, x, which was 20, plus c. Then we'll simplify it. We get 30,600 equals 20 squared is 400. 400a plus 20b plus c. All right, so now that we have 3 equations, let's go ahead and just write them all together. Equation A was 26,900 equals 100a plus 10b plus c. That was our equation A. Our equation B was 29,025 equals 225a plus 15b plus c. Okay, that came from my equation B. And then equation C was 30,600 equals 400a plus 20b plus c. Okay, and at that point, to solve a system, we need to make a decision about what variable we want to eliminate. Okay, let's look at our variables. We have lowercase a, lowercase b, and lowercase c. Which variable do you want to eliminate first? Let's go ahead and eliminate the variable c. So I'm just going to make that option known over here. I'm going to eliminate variable Okay, so let's start with these first two equations. I'm going to keep one c positive and then make the other one negative. So I'm going to take this second equation and multiply it by -1. I'm going to distribute -1 through to every single term. Okay, so in the first equation here, which is equation capital A, I'm going to leave it as 26,900 equals 100 lowercase a plus 10 lowercase b plus lowercase c. And then I'm going to multiply that second equation, capital B, by -1. Like, I'm going to change every sign. So I'll have negative 29,025 when I distribute the -1. I'll have negative 225 lowercase a. I'll have minus 15b minus c. So when I add those components together, what am I going to get? Let me type that in my calculator. 26,900 plus a negative 29,025. That's going to give me negative 2,125. Okay, add together the 100 with the negative 225. That new leading coefficient is going to be negative 125a. Add together the 10b and the negative 15b, get negative 5b, and then the c's get eliminated, which is what we wanted. Okay, this is still a two-variable equation, so right now I can't solve it. Okay, so I'm going to take a break and I'm going to pop over here and I'm going to eliminate the variable c again. But this time I'm going to use these two equations. Let's go ahead and this time let's leave the second equation the way it originally was. So I'm just going to copy the 29,025 equals 225a plus 15b plus c. And that third equation, let's go ahead and multiply it by -1. So equation capital C, I'm going to multiply everything by -1. So I'm going to distribute the -1 through to the first term. So that becomes negative 30,600. I'm going to distribute the -1 through to the second term. So I'll get negative 400a. I'm going to distribute it to that term right there, minus 20b, and then distribute it to the positive c. So I'll have minus c. Okay. Let's go ahead and add those together. All right, let's do 29,025 minus 30,600. We get negative 1,575 equals, let's do 225 plus a negative 400. I now get negative 175 as my new leading coefficient for A. Then we do 15 and negative 20, put those together, add those together, we get negative 5b, and then the c's get eliminated, which is what we want. Okay, so I'm going to label these new equations. This is going to be equation D, and this is going to be equation E. Let's make another decision at this point when we put these together. Do we want to eliminate A or lowercase b? Do we want to eliminate this variable or do we want to eliminate this variable? Which one looks easier? I think B. It would be nice if one said 5b and the other one said negative 5b. So let's go ahead and I'm going to multiply that equation D, that whole thing, by -1. So I'm going to imagine taking -1 and distributing it through to every single one of these terms. So I would have positive 2,125, I would have positive 125a, and I would have positive 5b. And then E, I'm just going to leave that entire equation the same. Negative 1,575, negative 175a, and minus 5b. Okay, again, I made the choice to eliminate the variable b. I'm going to add those together. Let's see what we get. 2,125 plus a negative 1,575. We get 550. 125a plus a negative 175a. We get negative 50a, and then the b goes away. Okay, so now when I divide both sides by negative 50, what am I going to get for a? We're going to get that a equals what? 550 divided by negative 50 is going to be negative 11 for a. Now, I'm not quite done yet. I've only found a. So how am I going to find the other two variables? Well, let's go back and plug it in. Once I get a, I'm either now going to go to equation D or E, since those are both two variable equations. Which one do you want to use? Let's go ahead and let's just use this equation E. I'm going to have negative 1,575 equals negative 175a, which now we know that a is negative 11 minus 5b. So this is going to be negative 1,575 equals 175 times 11 is 1,925 minus 5b. Okay, so I'm going to subtract the 1,925 from both sides. Whoops. So I get negative 3,500 equals negative 5b. And if I divide both sides by negative 5, I'm going to get that 700 equals b. Okay, so now I know a, I know b, and the last one I need to know is the variable c. So now at this point, I'm going to take both a and b, and I'm going to plug those in to one of the original equations, and you can pick any one that you want. Okay, so let's see, I'm just going to do the first equation. Okay, so when I plug it back into equation A, I'm going to have 26,900 equals 100a. A is negative 11 plus 10b. B was 700 plus c. Okay, and I'm going to use that equation to get what c is. So I'll have 26,900 equals, what is 100 times negative 11? It's going to be negative 1,100 plus, what's 10 times 700? That's going to be 7,000 plus c. Okay, let's combine like terms here. What's 7,000 minus 1,100? That's going to end up being 5,900. Okay, and if I subtract 5,900 from both sides, we end up getting 21,000 as our C value. All right. So let's go ahead and plug that all in to our original standard form. Remember, our original standard form looked like this. I'll write it over here. Y equals ax squared plus bx plus c. The only difference is remember we're using t and h to represent our x and y values. So everywhere I see an x, I'm going to replace that with t. And everywhere I see a y, I'm going to go ahead and replace that with h. Okay, and what did we get for A? A was negative 11. What did we get for B? B was 700. And what did we get for C? 21,000. Okay, and that's what I would put for h of t. You'll notice that for my plus signs, I don't curve them, whereas for my variable, I do curve it. So again, just so we can see that a little bit more closely, I'm going to put negative 11. When I write the t, I kind of put a little tail on my t. Then I have plus 700 t. Do you see how with the plus sign I did not put a tail, but again with the t I did? That's going to really help. And then we have the plus 21,000. So you can see it's kind of exhausting. We really want to be able to use vertex form or x-intercept form if possible, because otherwise the systems of equations takes a long time to get your parabola of perfect fit. Again, this was a perfect quadratic model. Okay, the last one says write an equation of the parabola that passes through the points negative 1, 4, 0, 1, and 2, 7. Here I'm given 3 points. I do not know the vertex and I do not know the x-intercept, so I'm going to have to use a system of equations to figure out what the quadratic Okay, the last one says write an equation of the parabola that passes through the points negative 1, 4, 0, 1, and 2, 7. Again, I'm only given 3 points. I am not given the vertex and I am not given the x-intercepts, so I have to use a system in order to write the quadratic equation. So just like the last example, I'll set up an xy chart just to organize it the same. We have negative 1, 4, 0, 1, and 2, 7. And we're going to be using standard form in order to help us write a system of 3 equations, or a system of 3 variables. So for the first equation, I'll call it capital A. Let's go ahead and I'll call it equation 1. We are going to plug in negative 1 for x, everywhere we see an x, and I'm going to plug in 4 for y. Okay, remember all of these coordinates are x comma y. So I'm going to write that my equation 1 is 4 equals ax squared, x is negative 1, plus bx, again x is negative 1, plus c. So if I simplify equation 1, what would that end up looking like? We would get y equals, what's negative 1 squared? That's going to be a positive 1a, and then b times negative 1 is minus b. We have plus c. Okay, let's do the same thing for equation 2. I'm plugging in Okay, so let's replace y with 4 on the first equation. So I'll have 4 equals ax squared, x was negative 1, plus bx, again x was negative 1, plus c. Let's go ahead and simplify that. That's going to become 4 equals, see, negative 1 squared is a positive 1, so I have positive 1a. This is going to become minus b, and then I have plus c. For my second equation, now my y value is 1, so I'll have 1 equals ax squared, x is 0, plus bx, x is 0, plus c. Simplify that down. We get 1 equals, see, 0 times anything is just 0, so really it's going to be 1 equals c. All right, and then lastly, 7 is my y value. I have ax squared, x is 2, plus bx plus c, again x is 2. So I'll simplify that guy down. And we'll get 7 equals, see, 2 squared is 4, so that's going to be 4a plus b times 2 would be 2b plus c. Okay. Now, this one's kind of tricky because see how we already have one of our variables solved for? That's awesome, actually, because I can replace c with 1 in the first equation and the third equation. So we'll call this equation 1, we'll call this equation 2, and we'll call this equation 3. In equation 1, if I replace c, I would get 4 equals a minus b plus 1. And really, I don't like the constants being on the different side of the equal sign, so if I simplify that again, I would get 3 equals a minus b. See how I'm already down to a 2-variable equation? That's cool. Okay, and in equation 3, I'm going to do the same thing where I'm going to replace c with 1. So I'll have 7 equals 4a plus 2b plus 1. Again, I don't want my constants to be on different sides of the equal sign, so I'll subtract 1 from both sides. And I get 6 equals 4a plus 2b. Again, I'm already down to a 2-variable equation, which is pretty cool. All right, so if I've got these 2 equations, I got to get it down to a 1-variable equation. Which variable do you think would be the easiest to eliminate? I'm going to go ahead and I'm going to eliminate b. It would be nice if this said minus 2b and this said positive 2b. Okay, you could do a's as well. You could make one 4a and one negative 4a. It's really up to you, but you want to make a decision. So I'm going to eliminate b. Okay, and how I'm going to do that is I'm going to take equation 1 and I'm going to multiply that whole entire thing by 2. And I'm going to leave that third equation the exact same. So I'm going to multiply this entire equation 1 by 2. Every single one of those terms. So 2 times 3 is 6. A times 2 would be 2a. And then negative b times 2 would be minus 2b. And that equation 3 I'm going to keep the exact same. 6 equals 4a plus 2b. Add those parts together. We get 12 equals 6a, and the b's cancel. 1-variable equation to solve, easy peasy. Divide both sides by 6, and we get that a is equal to 2. All right, so cool. Now I've got 2 of my variables solved for. Right? We had that c was 1 up here, and now I have that a is 2. So I have one variable left to find. I still have to find out what b is. Okay, so now I'm going to go back to one of these original 3-variable equations. Let's just do equation 1. So I'm going to use equation number 1. That was the equation 4 equals a minus b plus c. I'm going to plug in what I know now. I know that a is equal to 2. I don't know b. And I know that c is equal to 1. So I'm going to plug in 1. Let's just solve for b. 4 equals, combining the 2 and the 1, we would get 3 minus b. Subtract 3 on both sides, we get 1 equals negative b. And if we divide both sides by negative 1, we're going to end up with negative 1 for b. Okay. Final show here. Just have to plug in our variables that we just got into standard form. So we have y equals, what was a? A was 2. What was b? B was negative 1. So I'm really going to put minus x. And then c, that was given to us originally. C was equal to positive 1. And there you go. Again, system of equations takes quite a bit of time. Tomorrow, in our lesson tomorrow, I will show you a much quicker way to get your quadratic equation using the regression feature on your calculator.